Hi, my name is Sri Lakshmi. Today I am explaining the task given by the Spark Foundation, which is k-mean clustering using a dataset. Before going to any objective, I prefer to analyze the dataset that is given, what are the columns and rows that present the dataset. So here is my dataset, which contains sepal width, petal length, and petal width. So which are called features. Based on this, I am classifying the data set. So let's look at what an iris is. This is the iris family. There are three types of iris that look similar but have distinct characters. So I will group the similar flowers together. So here we have supervised and unsupervised learning in this. Supervised learning is a machine learning method that has trained data and unsupervised data learned by the experience. It is not trained data. So now I am using here not trained data. It's not trained. Based on measurement, I am grouping the data points and forming the cluster. Here are the data points. So based on the data points, I am finding the species column, that is the resultant column. So for now, I'll go for the actual task of what I have to code for the k-mean clustering. Import libraries. It is the basic step of the any Python coding. We need to import the libraries. Import pandas as PD. That actually allows you to load, clean, filter, transfer, and analyze the data easily. Import matplotlib. It allows you to create line plot, scatter plot, bar plot, etc. and so on. sklearn k-mean clustering is a unsupervised learning technique actually that groups similar data points together based on their features. And this PCA is a principal component analysis, is a dimensionality reduction technique available in the sklearn. NumPy as NP is a basic common library we'll import for the numerical values and scientific computing in the Python. Now I'm loading the data, that is iris CSV. This data set I already uploaded in my module. So here is my iris CSV. So this one I'm uploading here, and that is pd.read CSV. CSV is separated commas. The data points will be separated by the commas. And iris dot data dot head is displaying 5 rows. So here are the 5 rows. Iris data dot describe is the describe the total data set, and if I see the mean standard deviation minimum 25%, tail 50%, 75%. So this will be displayed. Iris data dot shape is the number of rows and columns. Here 150 rows and 6 columns are present in this data set. When I go for x equals to iris data dot drop. So IDs comma species are not required actually. So there are unrequirement because a species is the decision. After completion of that, we need to write the results in the last column. There is no need of those. Iris data dot is null is the checking the whether the dataset containing the null values or not. But present there is no null values in our dataset. It is very clean and clear dataset. There is no null values. So now I am finding the optimum number of clusters. Here is the IRI data is the index local. It is the local index numbers. This line extracts the values from the data frame. It selects all rows and columns with indices 0, 1, 2, 3. The selected values are stored in the variable. This line assumes the data frame. Import k-mean class is the module is class that implements the k-mean clustering algorithm actually. Initializing WCC within cluster sum of squares. The list will be stored the sum of square distance of the samples to their closest cluster center for each value will be stored here. So the for loop, as I know that this is a loop that iterates from 1 to 10, that excludes 11. It performs k-mean clustering for different values of the k number of clusters. Inside the loop, the k-mean object is created with a specified number of clusters. Other parameters such as int init k, maximum number of iterations is 300, number of times algorithms are there and will be run different centroid seeds 10, and a random seed is the state equals to 0 are also a set. The fit method is called on the k-mean object to perform clustering on the data. The inertia, which represents the sum, the square distance of the samples to the closest cluster center. Thus, the plot function is used to create the line plot, and it creates the plot within cluster sum of squares of different values. The plot function is used to create the line plot. It takes x-axis values and range from 1 to 10, y-axis values is and various formatting options such as we have marker type and lifestyle and also color and marker size. These are showcase. Additional codes at like x-axis label, y-axis labels are displayed the plot, and its function is the plot dot show. Here is our elbow method. So the overall purpose of this code is to apply the k-means clustering algorithm to the iris data. Use the elbow method to find the optimum number of clusters. Actually, the elbow method helps to determine the points of dimensioning the returns to the term of reducing. So applying k-mean clustering on the data within the cluster of squares, this line creates the objective name. Objective named k-means. The n clusters parameter set to 3. Indexes that we want to cluster the data into 3 clusters. The init parameter is set to be k-means plus plus, which is method of initializing the centroid. The max iter parameter is set 300, specified maximum number. This is the maximum number of the iteration for each run of algorithm. The n init is the parameter set to 10, indexing the number of times k-means algorithm will be run with different centroid seeds. The final results will be the actually best output based on the inertia. The random state parameter, this parameter is set to 0, which ensures the reproducibility by fixing the random seed for the centroid initialization. So this is the visualization the plot. This line plot, scatter plot the data points that belonging to the first cluster y k-means equals to 0 in the data set. The x-axis values are taken from the x-mean equals to 0, which selects the first column of the data points that belongs to the first cluster. The y-axis values are taken from the y-axis columns are taken from the xy equals to 0, 1, which selects the second column of the data point that belongs to the first cluster. Additional parameters are set already. I just discussed for styling the scatter plot, such as a marker size, color, marker, shape, and label for the legend. So this is a grid. The visualization is going to be on the grid display. So plotting follows similar patterns, but plot the data points for the second and third clusters respectively. So these are the centroids. These are the 3 types: iris setosa, iris versicolor, iris virginica. There are 3 types of flowers. This black is setosa, versicolor, and virginica. So these are the centroids. The k-mean clusters always calculated by the taking random centroid. This is the task given by the Spark Foundation, and thank you for the Spark Foundation for giving me this opportunity. Thank you.